Okay, let's simplify some radicals. First off, the fourth root of 64 x to the third y to the 6. Well, I do not see plus or minus, so 3 lines. Or 6 lines, my bad. So I have a radical. I need to get rid of the radical and rewrite it as a 1/4 power. The radical's coming back down here, maybe, but first I need to get this so I can apply my exponent properties. 64x to the third y to the 6th. Okay? Actually, I tell you what, switch that 6 on the y to a 5, please. Okay, just trust me. Make it y to the 5th. So we got 64 times x times y. Okay, so we got 1 times 1/4 is 1/4. 3 times 1/4 is 3/4. 6 times 1/4 is 1 and, or no, 5 times 1/4 is 1 and 1/4. Nice. None of these are negative, so they all just come over into position. X to the 1 and 1/4. Okay, now, your whole exponents are just the 1, y to the 1. Now the fractions, we got 1/4, 3/4, 1/4. So 64 to the 1/4 times x to the 3/4 times y to the 1/4. Okay, I always put the base with it. Now circle them bottoms. See if you can get rid of those right now. Right now would mean it has to show up on the 4 list, and 64 is not there, and x and y are not there, so they stay. Okay, well, we will not be doing anything here because we don't even have a base to worry about on bottom. Okay. All right, now, those ones that still, this is a whole, that just drops. That does nothing to do with the radical. Now, all these ones with radicals, they're all 4s, so I cross them all out and make a radical 4. I just need one of them. So 64 to the 1, x to the 3, y to the 1. Okay, so y to the 1. Now I make my radical 3. Now I circle the 64 to the first. I will be simplifying that, but for now I just put my x to the third times y to the 1. Okay. Alright, so I put my fourth root. It's 64 to the first, so evaluating that just takes me to 64. And then I try to make that into 2 radicals. Remember to look at your right list. It's 4. So 64, it's either 16 or we're leaving it. 16 actually works, so I put 16 and 4. What's the fourth root of 16? That's 2. So I will place a 2 factor out, and then that 4 stays in the radical. So there we have it. Beautiful. Okay, number 2, the fifth root of 32x to the 6, y to the 7th. So 6 lines. So we have 32, or first off, we need to get rid of the radical. So we make a parentheses to the 1/5, and I have 32. I have x to the 6, I have y to the 7th. So we have 32 times x times y, those are the bases. Then I'll be taking 1 times 1/5. Then 6 times 1/5 is 1 and 1/5. And then 7 times 1/5 is 1 and 2/5. Use your calculator on that. Okay, all these are positives. We're just bringing them over, because that's what I do. Alright, my whole exponents, I have a 1 and a 1, so that's a base x, base y, base x to the 1, base y to the 1. We'll have another base x and y because we have these fractions, the 1/5, the 1/5, the 2/5. Okay, circle those 5s on the bottom. We don't, these are whole. Okay, now check your 5 list. That's on the back side. Whoa. There it is. Okay. And base 32 is there, bro. It's equal to 2. So now the fifth root of 32 goes away, and we now have 2 to the 1 power. Okay, that 1 was on top, so it stays. Now the x and y ain't going to show up. Out. Okay. Full power, no radical needed. Full power, no radical needed. 2 is now a full power, no radical needed. Now when I get to those things, I cross out the 5s and I make a fifth root. And then I put x to the 1, y to the 2. And I think we're about good, okay? I mean, you have this 2 to the first, which becomes 2, but the x to the first, you could write it as x, and then the y. Then I make a radical with a 5, and I just have nothing but variables. So x, or x to the 1, times y to the second. Booyah! Okay, on to the next one. Okay, number 3. Remember, these are square roots. So the square root of 8y to the 5th times the square root of 40y to the 2nd. Okay, so again, no plus, no minus. So I'm going with the 6 lines. Now I got radicals and they're the same thing. So I make just one parentheses and I put a 1 over 2 power there. Now I can multiply, since they're the same radical, 2 and 2, I can multiply. 8 times 40 is 320, and then y to the 5th times y to the 2nd would be y 7. So now your bases, you have a 320 and a y. So 1 times 1/2 is 1/2, and then 7 times 1/2 is 3 and 1/2. Okay, so those will stay in the same place. And that whole exponent, okay, we place that. Now the fractions, 2 1/2 powers, one with a base of 320 and the other has a base of y. Okay, circle those 2's on bottom. Can we get rid of them right on the spot? No, we can't. 320 is not on the list. If it kept going, it still wouldn't be there. So they stay. Nothing I can do about them here. Okay, so now that's a whole. It does not get a radical. That's a 2, that's a 2, cross them out, and we make radical 2. And then 320 to the first, and then y to the first. Now, y to the third can't be simplified. Now I make my radical, and inside the radical we actually have a base number, which we will try to simplify. So I'm going to have the square root, okay, the 2 root. 320 to the 1 is 320. Now let's see if we can divide, okay. So 320, eventually you get to 64. Divide by 64, you get 5. So that turns into 8. So we have moved 8 out, 5's in. Donezo. Okay, hint, hint, hint. The 7th root of 7 times the 3rd root of 7. Okay. Yeesh. Okay, there's 2 parentheses because you have a 7th and a 3rd. So one is to the 1/7 and one is to the 3rd. So you can't take the 7 times the 7. Okay, you have 2. You keep the base 7 separate and you add their powers. So 1 times 1/7 is 1/7. 1 times 1/3 is 1/3. So I would be adding a 1/7 to a 1/3. 10 over 21. Wow. Okay, so that's staying. And obviously we have a fraction, but I don't think your teacher gave you a 21st sheet. Okay, I don't think I did that. Okay, so guess it stays. And we have a fraction, so we get rid of the 21 by making a radical 21, and we have 7 to the 10th power. Okay. Now you're like, how am I supposed to simplify this? You're not, because I didn't give you a list for it. Okay. Just don't write that. Just keep it as 7 to the 10th. Okay. My bad. That wasn't a good one. I wouldn't put that on a test. Well, I put one light set up like that, but you know, if you get in, I mean, you could put it. I mean, you can go 7 caret 10, and yeah, pretty big number, 282,475,249. You could write that in there, but I wouldn't worry about simplifying it because we don't know the 21s. Okay, number 5, we have the square root of y to the 3rd divided by the 4th root of y to the 3rd. Okay, so again, 6 lines here. So hint, 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 you need to keep them separate because you have 1/2 and 1/4. Now you're going to put y to the 3rd and then y to the 3rd. So we put a y over a y, we keep the bases separate. So we take 3 times 1/2, which is 1 and 1/2. 3 times 1/4 is 3/4. Now this guy can go, but then we have to subtract 3/4. So 1 and 1/2 minus 3/4. 3/4, okay? Obviously not a negative, okay? And the fraction's the only one you got, so you bring it over here, circle the 4, but you can't get rid of the 4 at this point just by getting rid of it, okay? You'll have to make that into a radical because I don't have that. Okay, get rid of that, make a 4th root out of it, and y to the 3rd, and we got a nice answer because I just have the variable, so I don't have to simplify it. Okay, number 6, 32 to the negative 4/5 power. Now, I do not have a radical like I did on these first 5, so I'm not rewriting it at all. Don't touch it. Just put 32, negative 4/5, send it to the bottom where it becomes positive 4/5. Okay, so fraction's all you got. It is on the bottom, but first check and see if you can get rid of that. Look up the 5th root, the 5 sheet, and see if 32 is there. It is. It's equal to 2. So that's gone, and we now have 2 to the 4th, okay? Remember, the 4 stays there. Now, you might want to check this, but we don't have to do anything because the exponent I have is a whole. It is not a fraction, so it's already whole. I don't need to do anything. Okay, that is a whole. It does not need a radical. And then you find what 2 to the 4th is. That's 16, and then a 1. The radical is only used if we still have a fraction where we couldn't eliminate the bottom. Okay, y to the 1/2 times y to the 3/10, so it's all multiplication. Okay, you see a radical. I do not see a radical, so we do not put anything in the problem. Okay, is that clear? You got 2 base y's, and you add their exponents. So what's 1/2 plus 3/10? I think it's 4/5. Yep. Keep it where it's at. Fraction's all you got, so when you're bringing it over here, circle that bottom. So I can't get rid of the bottom just by using my sheet, okay, because it's not, the y is not a perfect fit. Okay, nothing on bottom. Now to get rid of this 5, you make it into a radical of a 5, 5th root, and then y to the 4th. I ain't simplifying nothing, okay. Okay, number 8. We got a parentheses. On top we got 8x to the 12th, y to the 4th. Okay. On bottom we got 27x to the 2nd, y to the 16th. Okay. Alright, now we have to use the 6 lines, but I do not have a radical that I need to get rid of, so don't put anything new into that. Okay. So you're putting in equals and writing it off this side. I don't need to do that. It's already set. Okay. So you've got 8 times and 27 as your numerical bases, and variables x and y on top. They're also on bottom. That's okay. We can cancel them. So 8, 1. 1 times 2/3 is 2/3. 27. 1 times 2/3 is 2/3. Now I take 12 times 2/3, and that gives me 8 whole. And then 4 times 2/3 gives me 2. And tell you what here. Hold on a second. I want to make sure this is right. This will work out okay. 2 2/3, okay? And then 1 times 2/3, x, 2 times 2/3 is 1 1/3, and then 16 times 2/3 is 10 2/3. Okay, cancel, cross out your x to the 1 1/3, and you minus 1 1/3 from 8. That's 6 2/3. Now, ditch your 2 2/3, and you get a nice break here. 10 2/3 minus 2 2/3 is 8 whole. So 8 whole. Use a calculator if you're not good with fractions. Okay, all these stay in position. The 8 stays in position. The x to the 6 2/3 stays in position. And then 27 to the 2/3 stays in its position. Then y to the 8th stays in its position. So the full exponents I have are 6 and 8. So I have x to the 6th, y to the 8th. Now put the fractions. So you still got 2/3 on top with a base 8. You have 2/3 on top with a base of x. And you have 2/3 on the bottom with a base of 23. Now, those are wholes, leave them. But these ones with fractions, we need to see if we can eliminate them just by looking at the sheet. So I know I can't do the x, but maybe the letters. The cube root of 8 is 2. Okay? So now it's 2 to the second power. No, that's no longer a fraction. So it will not be, I don't need to make a radical out of it. Then 27 is also there. It's 3. So 3, and we still got that little 2, so it's 3 to the second. Now, do I need to use this line? Well, I've got some bases on bottom, but that's a whole, and that's a whole, so I don't need to use it, okay? Okay, now, what needs a radical? That's a whole exponent. That doesn't need one. That's a whole exponent. That has nothing to do with a radical. Fraction. So now I get rid of the 3, make a radical 3, and now I place the x to the second. That's a whole, does not go in a radical. That's a whole, does not go in a radical. Okay, so 2 to the second and 3 to the second need to be simplified. That'd be a 4 and a 9. Then the x to the 6 doesn't get simplified. The y to the 8th cannot be simplified. And the cube root of x to the second can't be simplified. And that's the end. Okay, number 9. The cube root of x divided by the cube root of 2 doesn't seem like much of a problem. So we're using the 6 lines because we don't have any plus minus. Now, we're back to having radicals, so I need to put an equals, and I just need one parentheses because all we have is a third. But you can't really simplify it, just be x over 2. Okay, so we have x on top, 2 on bottom. So 1 times 1/3 is 1/3. 1 times 1/3, 1/3. Okay, I don't know about you guys, but I don't think these can change positions. Be nice if that one would, but it doesn't. Okay. So no whole exponents, both fractions. Remember to be circling the bottom. Now check your cube root. You know the letter isn't there, but 2 is not there either. I don't look for that. I'm looking in the red. 2 is not a perfect cube. Well, you got a base on bottom and it's not a whole, it's a rational, so we actually have to do something there for the first time. So I write my x to the 1/3, okay? And then I put my base 2 to the 1/3, and I make it whole by timesing by another base 2, putting a 3, and what's 3 minus 1? It's 2. So this times 2 to the 2/3 power. Now don't multiply the 2's. It stays at a base of 2, but we add the powers because 1/3 plus 2/3, watch this, is 1. Okay, alright, so now you got your whole. That does not, now I don't have to make a radical. You never want to make a radical on the bottom. That's why you make it whole. Now we still got fractions on these, but we're about to get rid of them by making a cubed root. Please put your 2 to the second before the x to the first. The numerical base goes first. Okay. And we make a cubed root. We know we have 2 on bottom. X to the first, you can just put x if you want, or keep it to the first. You do you on that. Then I make a cubed root, and I have to try to simplify 2 to the second. Well, 2 to the second evaluates to 4. But I do not believe 4 is too small to divide. So if it doesn't divide, you don't do nothing. You just keep the 4 where it's at. Okay. Okay, now this speeds up a little bit because number 10, 18, the square root of 2mn minus, so the minus means a plus negative, 25, square root of 2mn. So now the game changes because I have a plus, so no 6 lines. Mark your radicals, and they're the same, so that makes for a super simple problem. You write the radical down and you add the outsides. 18 plus negative 25 is negative 7. Booyah. Okay, the square root of 50 minus, or plus negative 4, square root of 18 plus 2, square root of 32. We got pluses here, so I need to check the insides, but unlike the last problem, they're not the same. So I need to go off the side here, make a little chart, and simplify each of my radicals. So I've got the square root of 50, negative 4, the square root of 18 to the square root of 32. Okay, don't have a coefficient here, so you just go right to your two square roots. Okay, got a -4 here. So I write times and then make my two square roots. 2, make it times, write your two square roots. Now you're on the 2 list. So 50 divided by 49, nope. Divided by 36, no. Divided by 25 is 2, so 25 and 2. So the square root of 25 is 5. Okay, so we have 5 radical 2 over 2. Okay, and then 18. So 18 divided by 16 decimal. 18 divided by 9 is 2. Okay. So square root of 9 is 3. So we have -4 times 3 times the square root of 2. So you need to multiply your, by the way, cross that out and put 5 square root of 2. Okay, -12 square root 2 plus, so you're just rewriting. And then 32, we're going to start at 25. Doesn't work. 16 and 2. Okay. So square root of 16 is 4. So you have 2 times 4 times the square root of 2. So 2 times 4 is 8, square root of 2. Okay. Okay, put your square root of 2 down. Okay. And then you add the outside. So 5 plus -7 is -12 plus 8 is actually -7 plus 8 is 1. So 1 square root of 2. Or you could just put the square root of 2 if it ends up as a 1. Now, Hermson helped you out a little on this one. You do the FOIL, but first you need to break down the square root of 72. That did not have a, I'll put a 1 there. Okay, you put a 1 over there, because you don't want to FOIL without coefficients. You're going to want those in there. Okay. So I put a 1 right there. Not that it's really going to matter, but so I divide 72. So 72 divided by 64, you're on your 2 list if there's not a degree. And 2. Okay, so the square root of 36 is 6. 1 times 6 times the square root of 2, so that's 6 square root of 2. So you need to rewrite this problem. Everything's the same except that one needs to turn into a 6 square root of 2 times 5 plus 1 square root of 2. Now we start FOILing. Okay, so 1 times 5. 1 times 1 square root of 2. Then 6 square root of 2 times 5. And then 6 square root of 2 times 1 square root of 2. So 1 times 5 is 5. 1 times 1 is 1 square root of 2. 6 times 5 is 30 square root of 2. 6 times 1 is 6. Guys, you don't keep it at square root of 2 when you're that's an adding thing when you keep it at the square root of 2, because when you have 2 square roots of multiplication, you need to multiply the insides. 2 times 2 is 4. But that's not, these are simplified, but that one's not, because the square root of 2, 4 is equal to 2. So 6 times 2 is 12. So we combine the 5 and the 12 to make 17. Now I'm adding, so now I keep it at the square root of 2. And I take 1 plus 30, that's 31, and I will not, don't add the 17 and the 31. Keep them separate, because you can't, those are not like terms. That's multiplied by a square root of 2. That one is not. Okay, number 13, the square root of 128 minus or plus negative, okay, and then the square root of 50. You can put 1s if you want, but you're just trying to make them the same, okay? So, bring them over. So you got the square root of 128, and then I would put a 1 in front of that. So it's -1 square root of 50. You can put a 1 in front of that too, it's not going to matter, okay? Okay, so 128, what can that divide by? You go up the list, you get decimals till you're at 64, because 128 divided by 64 is 2. So I fill the radicals in with 64 and 2. So the square root of 64 is 8. So you end up with 8 square root of 2. Then negative 1. I'm going 50. 49, 36 don't work. 50 divided by 25 works. 25 and 2. So the square root of 25 equals 5. So it's negative 5 square root 2. So now you got turns into an 8 with a square root of 2. Then a negative 5 with a square root of 2. And now that these are the same, now I keep them the same because I'm adding. Okay, remember multiplying, you have to do the inside operation. But now 8 plus negative 5 is 3. All right, now we're solving equations. Okay, so we have the square root of, that means solve for x. Square root of 2x plus 3 minus 7 equals 0. So first, I put a wall on the side of my radical, and I circle the radical. Now, before I worry about the radical, I got a minus 7, so I need to plus 7. And then I get rid of my square root with a 2 power. Then that will get me on the right track. So I add 7, and that takes us to 7. Now, you cancel out your 2 with the second power, but you got to remember to take the 7 to the second. Please, okay? So that becomes 2x plus 3, but the other side you need to take 7 times 7. That equals 49. Okay, so it's just x to the first power, so I can apply linear properties. That's when I just get the x by itself, times 2 plus 3, so I'm minus 3. We're at 46. Divide by 2, and 46 divided by 2 is 23. Next one, 3 times the parentheses x minus 2 to the 3/4 power equals 24. Now we will not be distributing because we have a power to the parentheses. That is when you want to bring in your h. Okay? So 3 times h to the 3/4 power equals 24. Now when you're bringing in your h, you got to remember to bring back the x minus 2 expression. Okay, we might need this side, we might not. We always did in the first semester because it was a square root. Okay, that's an even root, but now it might change. So before I worry about the power, we got to get rid of the times 3 by dividing by 3, and that would take us to 8. Now we get rid of a rational exponent in an equation by simply taking both sides by flipping the exponent to 4 over 3. So it would be to the 4 over 3 power. Now is when we can decide whether that sign is needed. You're going to look up the third root of 8. That's an odd root. Okay? So if it's an odd, you can cross this side out before we even look it up. Okay? That's even, because I'm going to be looking at cubed roots. Those are only the one value. The cube root of 8 is 2, so it can only be a 2. But it's still to the 4th power. So now I take 2 to the 4th power. 16. Okay, why don't you put your 16 there? So plus 2, that's 18. Next draw page. We have the square root of 3x plus 7 equals x minus 1. Okay, so a square root, we circle the radical. Don't have anything outside, so I go right to the 2 power method. So 2, and over here we put a 2. Now that side cancels, and I have just what's under the expression under the radical. But over here we don't have just one value, we have a binomial, so we need to take x minus 1 times itself. So I FOIL it, x times x times negative 1, negative 1 times x, negative 1 times negative 1. So that's x to the second, negative 1x, negative 1x, and 1. Okay, combine those, negative. It doesn't cancel, they're both negatives, so it makes a negative 2x. And now we have two answers. Now we have x second, but we've also got x, so we can't use linear properties, we have to factor. Okay, so clear this side. So minus your clear whatever side is with the x, whatever side the x squared isn't. Then I subtract it from negative 2x minus 7 from 1. Okay, so we have x to the second, be a 1. Negative 2 minus 3 is negative 5. 1 minus 7 is negative 6. Now you're factoring three terms. GCF table. Okay, negative, nope, x, no negative, just 1. So 1 times negative 6 is negative 5, so it's a positive by a negative. And the factors have to add to negative 5, and 1 and 6 do that. Okay. Now, so I make my parentheses. So I've got plus 1 minus 6. Okay. 1x to the second, you can delete the 1. X, get rid of it, okay, because you can't simplify. So now you've got x plus 1 times x minus 6 equals 0. Now you got your, apply your zero product property. So you get negative 1 and positive 6. Okay, and the graphing in this video is over. Y equals 2 square root of x plus 3. First, just make a y equals x with a square root over it. That's your parent. So you want to start with the parent. No negative inputs on a square root. 0, 1, and then pick perfect squares. Because that's easy. If I put a 9 in there, the square root of 9 is 3. Put a 4 in, you're at 2. 1, 0. Now, we have to make do the d and r over here for later. Okay, now do you have anything inside the radical? Nope, so the x stays. Those will stay the same. Now outside you got a times 2, a plus 3. Now remember, outside, those are outside. Those do the same operation to your y values. So you times 2 first, then you plus 3. So that's going to be 6 plus 3. That's going to be 9, incidentally. 4 plus 3 is 7, 2 plus 3 is 5, and then 3. Okay, now if you want to mentally calculate it, if you put a 3 in for x, the square root of 3 is 9, or the square root of 9 is 3. Okay, 9 goes in, but that becomes a 3, and 2 times 3 is 6, 6 plus 3 is 9, likewise with the 4. Okay, do your 0, 3 first. You can go by 1s on both of these. Remember, that's the restriction point. Then 1, 5. Then 4, 7. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. And then 9, 9. And you keep going this way, but you're restricted that way. So I know 0 is the x restriction value, and 3 is the y. Now you can either say, gee, are these numbers bigger than 0 or less than 0? They're bigger, okay? And so it's going to be greater than, or you can make it, split it into a right, left half. They're all to the right, so that'd be greater than or equal. Now the y value is 3. Are all these other values bigger than 3? They look like it to me, so it'll be greater than or equal to. Or if you don't like that, you can make a up, down, and all points are above. Okay. All right, last one. Number 18, y equals the square root of x plus 1 minus 5. So again, start with just a square root without any of the operations. Okay, so it's only used, we can't put any negatives into a square root, into any even root for that matter. And then 1, 4, 9. So it'd be 3, 2, 1, 0. Now, inside you have an operation. Remember, inside does the opposite to the x. So if it says plus 1, we're minusing 1. Now outside you have a minus 5. Outside does the same to the y. So you don't switch them outside to minus 5, to plus 5, you minus 5. So it's 8, 3, 0, negative 1. Then it's going to give us negative 2, negative 3, negative 4, negative 5. Remember, negative 1, negative 5 should come first. 1, 2, 3, 4, 5. That's your restriction point. 0, negative 4. 3, negative 3. Okay, 8, negative 2. Okay, so there you go. Now domain and range. Okay, so negative 1, negative 5. You can tell all these points are bigger than negative 1, so you know that'll be greater than or equal to, or you can split it. You see they all go to the right. Right is greater than on x. And then negative 5, all those are bigger than negative 5, so that'll also be greater than. You can tell it's going above that point, so